Good morning, dear students. In the last class, we discussed about the real numbers, what is the meaning of real numbers, and also we've seen some examples of real numbers. And I told you to write 50 real numbers, example of real numbers. I hope all of you done that. Okay, now what is real number? So real number are simply the combination of rational and irrational numbers in the number system. Okay, this thing we learnt in the last class, last video. Now we'll move on to the decimal expansion of this real number. What is this decimal expansion? Okay, in today's class, let us learn about the decimal expansion of real numbers. So here we have 10 by 3. 10 by 3 is it a real number? Yes, it is a real number. It is of the form p by q. It is a rational number also. Now we have to do the decimal expansion. It is in the form of p by q. We have to write the decimal expansion of this 10 by 3. How to write the decimal expansion of 10 by 3? It is very simple. So that is you have to divide this. So 10 divided by 3. So divide this. So 3 3s are 9. Remainder, subtract here, remainder 1. So this 1 is not divisible, so take point. So I'll get 0. Again 3 3s are 9. Remainder 1. So already you took a point here. So we have the axis to take 1 more 0. So once if you take the point, so you have the axis to take the 1 0. So therefore it is 9. So it's keep on going like this. So the decimal expansion of this is 3.33333 like this. Okay, this is one type of decimal expansion. Here we have one more type of decimal expansion, that is we have to expand this 7 by 8. So here 8 is not divisible by 7. I took the point, so the decimal expansion is 0.875. So we get the remainder 0. Okay, we have one more. We'll take one more example. Here just look into this example, 1 over 7. If we divide 1 over 7, it is not divisible, so I took the point. So I got that 0.142857. Again it starts from 1. If we continue this, so you'll get like this, 142857, 142857. Till where it will get? It is not terminating, it will not end. So it's keep on going. Okay, now tell me, what is the difference you seen in these three examples? So here take 3.33333, it is not terminating. Terminating in the sense it will not stop. If you do the division 1000 times, the 1000 times also will get the same answer. And here after certain steps, it will terminate. And here it is not terminating, but it is repeating. So we seen here three types of divisions. So one is terminating, non-terminating. This is terminating. This is what happened here. So it doesn't repeating here. Sorry, it doesn't terminating, but it is repeating after certain points here. 142857. Again you'll get the 142857. If you do the 1000 times, you'll get the same string. These are the three different types of decimal expansion we can see in real numbers. Here the case 1, the remainder becomes 0. So in this case the remainder becomes 0. In the example 7 by 8, we found that the remainder becomes 0 after some steps, and decimal expansion of 7 by 8 is equal to 0.875. Other example is 1 by 2. Like this you'll get so many examples. So this cases the decimal expansion terminates or end after a finite number of steps. We call the decimal expansion of such number as terminating decimal expansions. Now see the next case, the first example and the last example. The remainder never becomes 0. In the example 1 by 3, Okay, especially in the 1 by 3, then okay, 1 by 3 and 1 by 7, we notice that the remainder repeat after a certain stage, forcing the decimal expansion to go on forever, go on forever. So in other words, we have a repeating block of digit in the quotient. We say this expansion is non-terminating recurring decimal expansions. I'll repeat once again. In the example 1 by 3 and 1 by 7, we notice that the remainder repeat after a certain stage, forcing the decimal expansion to go on forever. In other words, we have a repeating block of digit in the quotient. We say that this expansion is non-terminating recurring. So these are all the example of non-terminating decimal expansion. Non-terminating, and also one more word, that is recurring. Why? Because here this is 3.333, here 3 is recurring, and also you can write this as 3.3 bar. Why? Because this after decimal this 3 is repeating, and even here also you can write that 0.142857 bar. Why? Because this bar indicates that this many digits will repeat cyclically. I hope all of you understood about repeating, non-repeating decimal expansion of real numbers. Yes. So I'll give some problems. So just check with that and tell me that whether it is a repeating decimal expansion or non-repeating decimal expansion. So here are the some homework problems. Yes, here I assigned you 6 problems. So please check and solve all these problems. Okay, I hope all of you do this. Yes, thank you all. We'll see you in the next video. Bye, take care.